My dear students, uh, today we'll discuss few more concepts related to the that is Fourier series representation of periodic signals. All almost all we have discussed all the concepts which are there in the third module. The only one concept we have left in the discussion of the Fourier series representation for periodic signal is that we have not solved the problems related to DTFS, that is discrete time Fourier series representation of the signal. That is, we have discussed about the properties of DTFS and so many other concepts, but we have not solved the problems related to the DTFS, that is a discrete time Fourier series. One problem, that is such problems will be asked in exam, so many different types. But means here example I'm telling one solution how we can solve the problems related to DTFS, but in exam they may give the different signal. They give, for example, give different signal, and from using these steps you have to find out the solution for the problem. Here they have given the different. Here find DTFS of coefficients of the signal shown in the figure. So at that time, so they will give such signal, discrete time period of sequence of. So if they give such in here also they have mentioned in V2 exam, July August 2000, March 5, January February 2003, 10 March, like this. In this is the book, V2 book. This is the V2 book. In V2 signal system, as per revised syllabus of Vishweshwara Technological University, semester 5th, triple A, semester 4th for EC, TC, and IT. Important. See, this is the best book. Best. Why I'm telling, because so many books are there, but here the video books they have written, we can understand the concepts very easily. That's why we have to refer. But actually, whatever concepts are, we have to refer from standard books. For your reference, the book is what, the Alan of Oppenheim. What is that? Alan Oppenheim, Alan V. Oppenheim and Wilhelm and S.H. Nawab signal system. This is your reference book. This is the test book. From this book only, they will ask the questions from this book, standard book only. It is for your reference. But here, suppose you refer this book, you can't understand the concepts easily. Therefore, to understand the concepts, you have to refer such video books, or even in reference book Simon Hacking. Simon Hacking is also the best book for signal systems. When we are studying, it is Simon Hacking and Barry Van Veen, Signal System, John Villa and Sons, 2001. And other books are also there. BP Lathi is also there. When we were studying in B, we don't have like this Alan V. Oppenheim was not there. We referred the Simon Hacking, the BP Lathi for signal system. Our teachers have referred such books. Now, when we were students at that time, no good books to refer. Only the books are there. Those are written by the foreign authors. But nowadays you are very lucky, because so many books are available on all the subjects. Whatever it is, signal system, field theory, computer communication network, in all subjects, so many books are there. Only thing that is, you have to do hard work, you have to read, you have to understand the concepts. It is your duty to do, that is, you should read, understand the concept, practice the problems, then only we can score good marks in the field theory, signal system, whatever subject. Therefore, like they will ask different problems, they will give such signal and ask you to find out, that is, find the details of coefficients of the signal shown in the figure. If in the exam they will give such sequence. From that, you have to obtain its find DTFS, find DTFS coefficients of the signal. Like this, at that time you have to do the solution of all this. That is like this. Yes. This is how you have to find out the solution. Find the DTFS coefficients of the signal shown in the figure. Like so many problems like they will ask determine the DTFS coefficients to evaluate DTFS representation following x of n. They will give x of n, then you have to find out the coefficients means these values. You have to find out what are the values of that is here. What is the value of x of minus 3, x of minus 5, x of minus 2, 4? Like you have to find out these values. That is like here also we have find out what is x of 0, x of 1, x of 2. Like we have to find out all these values. Okay, then today we'll some problem we'll solve one problem related to that is DTFS. That is determine DTFS representation for the signal. That is x of n equal to cos n pi by 3. Plot the spectrum of x of n. Here they have given a sequence, they have given a signal x of n equal to cos n pi by 3. We have to find out what its DTFS. Therefore, and also we have to plot the spectrum. Then now how we can solve this problem? The solution is the given signal is x of n cos n pi by 3. They are given this is the signal. We have to find out details of this. Determine DTFS representation of the signal. Then to obtain period n, cosine function also can be written as x of n is equal to cos. That is x of n is equal to cos theta. Here theta is what that is. We can write x of cosine function as x of n equal to cos 2 pi fn. 2 pi fn. Comparing the two equations, this is here this equation and this equation. From this equation what happens? Take this here in place of x of n, write this cos n pi by 3, cos n pi by 3. Here already what? Cos 2 pi by 3. Therefore cos get cancels. Therefore we left here we are then f is here, n also get cancelled. Here n is there, here also n is there, get cancels. Then we are left with 2 pi fn equal to n pi. Therefore here f equal to will get what? N get cancels. We are left with what? 2 pi f equal to pi by 3. Therefore f equal to pi by 3 into this. If it comes this side, then will be it is 1 by 2 pi. Therefore it is equal to 1 by 6. F is equal to 1 by 6. Therefore thus the frequency is the ratio of two integers. Here the frequency is the ratio of two integers. Therefore hence the given cosine wave is periodic. While how we can find out while discussing about the properties of the signal, we discussed about various types of signals are there: periodic signal, non-periodic signal. So many different types of signals are there. At that time we discussed about deterministic signal, random signal, even signal, odd signal. Like this we have discussed so many signals. In that what is the condition for a signal to be periodic? That is, the signal should be the f of x equal, it should be expressed the as a given thus the frequency of the frequency is the ratio of two integers. This should be in the form of integers. It should be the ratio of two integers. Then only we can tell this signal as a periodic signal. Therefore, here hence given cosine wave is periodic. And for such signal, f equal to k by n equal to here 1 by 6. Means here k value is 1, n is value is 6. Therefore, n is what? N is nothing but the period of the signal. Here n is equal to 6. From this equation, we come to know what is the value of n. N is equal to 6. Therefore, n is equal to 6. This is nothing but the period. Period of the, what is period? The time taken to complete one cycle is called as period, time period. Then omega naught equal to 2 pi n by 2 pi by n. Here 2 pi by n. That is we know that is what, how we can obtain this. That is, for example, I will show how we got this. Simple concepts. How we got this one here, for example, you see here, omega naught. Omega is, suppose omega is there. Omega equal to 2 pi f. Omega equal to omega, that is f. Omega is what? The angular frequency. F is the normal frequency. Omega is angular frequency. Therefore, omega equal to 2 pi f. But f is inversely proportional to f is, here see, f is inversely proportional to t. F is inversely proportional to t. That is, therefore, in place of f, I will write 1 by t into 1 by t equal to 2 by t. 2 by omega equal to is called, in place of f, I will 2 by f. F is inversely proportional to 1 by t. Frequency and time are inversely proportional to each other. Therefore, in place of f, I will write what? T. That is 1 by t here in place of f in this equation. Then it will be omega equal to 2 by t. Like it is, we are expressed like here also. N is there. N I will write omega. I will write as, that is 2 pi by n. I will write omega as 2 pi by n. Here also they have written that is same thing, 2 pi by n. Why? Because, but you see here omega is there. Here this is omega. This is also omega. This is also omega. But while discuss here, but here we are represented like this. Symbolically we are represented like this. There here in while discussing about the DTFS, we written omega like this. Why? Because that is in DTSF representation. Symbolically we represent angular frequency as like symbolically, like we represent like this. While discussing about the discrete time signal, we represent the angular frequency by this symbol. That is, this is because we are discussing about the DTFS. In DTFS, we will represent by angular frequency as omega naught equal to 2 pi by n. 2 pi by n. Same thing here also. Omega equal to 2 pi f. In place of f, I will replace it by 1 by t. Therefore, t is here. T is what? T is here. T is n. Here, there t was there. Here n. Here also we represent the time period as n. There in CTFS, how what symbol we have represented by? T represents the period. Here n represents the period of the signal. Therefore, here 2 pi by 6 equal to, we'll get this one equal to omega not equal to pi by 3. 2 divided by 6 is there. 2 1s are 2 3s are. Therefore, we will get pi by 3. This is what our omega naught. Then to express x of n in the form of series, to obtain the DTFs in the form of series, then what we have to do? We know that cos theta, we know from formulas. Here in a single system, you should know the various formulas, mathematics formulas. Because in solving problems, you have to use those formulas. You have to apply the formulas. Therefore, you should be perfect in mathematics. Then only signal system is very easy for you. If you are weak in mathematics, then this subject will be very difficult for you. Therefore, we know that cos theta equal to e raised to j theta plus e raised to minus j theta by 2. This is the equation of cos theta. Then here in place of theta, what we have to write in place of theta, we have to write cos omega n, cos omega naught n. Then if it is like this, in place of theta, we have written what? Omega naught n. Then therefore, what will be the equation for cos omega naught n equal omega naught n? Then this will be equal to, if this 1 by 2 is there, it is common to here. Suppose you elaborate this equation, it will be e raised to j theta by 2 plus e raised to minus j theta by 2. Then in place of theta, what we have to substitute? Omega naught n. Then this equation will be 1 by 2 e raised to j omega naught n plus 1 by 2 e raised to j, in place of theta, what we have to write? Omega naught n. Therefore, we have obtained the expression for cos, we expressed the cos omega naught n like this. And that your function is what? This. Therefore, x of n is equal to x of cos n pi by 3. Therefore, this is our signal x of n. X of n equal to 1 by 2 e raised to j omega naught n plus 1 by 2 e raised to minus j omega naught n. This is our Fourier series. That is, we can this is our express x of n we express in the form of series. Then x of n equal to this equation we got. Then to obtain the Fourier series, discrete Fourier series, DTF means discrete time Fourier series, then that will be equal to x of n summation of x of n x of k e raised to j k omega naught n. This is the equation to find out the what? The Fourier series of a discrete time signal. Then here n is equal to 6. Why n is equal to 6? I am taking summation over k equal to, why n is equal to 6? We know that from it is a periodic signal with the period of it is a periodic signal with the period of n is equal to 6. Well, here we have obtained this here n is equal to 6. Therefore, he got for n is equal to 6 means we have to take two 6 values will be there for here summation of 6 values. And taking summation over minus 2 to 3, that is consecutive 6 values. We have to take 6 values. You can take either 3 to 2 or something, minus 3 to minus plus 2 or minus 2 to, like this we can take, but the period should be, the sequences should be, the values should be, that is what the consecutive 6 values should be only 6. Therefore, here for our I will take here the value of k as minus 2 to plus 3. Minus 2 to plus 3 means how many sequences, how many values, consecutive values here, that is minus 2. I will write here for your understanding purpose. Minus 2, minus 2, minus 1, 0, 1, 2, 3. Minus 2, minus 1, 0, 1, 2, 3. How many values? 1, 2, 3, 4, 5, 6. Therefore, we have to take the 6 values. Therefore, since why we have to take 6 values? Because the period period of the signal is 6. Therefore, we have to do summation from my k of my 0 equal to k equal to minus 2 to plus 3 x of k e raised to j k omega naught n. Then elaborate this equation. Summation means we have combined all these equations in a single equation. Then we will elaborate this equation, substitute the value of, first what we'll do, substitute the value of k as minus 2, then it will be x of minus 2. In place of k, substitute the value of 2 here, x of minus 2 into e raised to j k omega naught n. In place of k, what we have to substitute? Minus 2. Then this will be e raised to minus j omega naught as it is, n as it is, 2. 2 minus sign we have taken outside. Why? Because value of k is minus 2. Similarly, plus now after one value we have got this expression for, then we will take one more value. How x will get? How we will get? We will take the value of k as minus 1. Minus 1 k, x of minus 1, then substitute the value of k is minus 1, then e raised to minus j omega naught n. Since 1 is there, you will no, if you write, you don't write, no changes in this expression. Then next is 0. K is equal to 0. K is equal to 0. If you write here k is equal to 0, then the entire term becomes 0. Therefore, e raised to 0. Next, what we'll do, we'll substitute the value of k as 1. Then it will be x of n e raised to j omega naught n. Then plus we will take one more value, value of k as 2, x of 2 e raised to j omega naught. In place of k, I will write 2 n. Then plus I will take x of 3, k value as 3, then it will be x of 3 e raised to j omega naught 3n. 3 in place of k, I will substitute 3. Then when we elaborate this equation, this expression, we'll get all these values. We get all this, where is 6 values. Then comparing the above equation, this above equation and equation 4.3.13, we find that where is 4.3.13? Here, 4.3.13. This is our signal. What is the signal? X of n equal to 1 by 2 e raised to minus j omega n plus 1 by 2 e raised to minus j omega naught n. This is our signal here. Therefore, then we'll find out what are the values of this x of minus 2, x of minus 1, x of 0, x of 1, x of 2. We'll find out what are the values. Then suppose you see here in this expression, x of minus 2 e raised to minus j omega naught 2 n, we don't have any value in this expression. Then suppose you consider here x of minus 1 e raised to minus j omega naught n. Therefore, here x of minus 2 are taken as 0, because here no such expression is there in this signal, in this expression. Therefore, x of minus 2 are taken as 0. Then x of minus 1, comparing this x of minus 1 into e raised to j minus j, when comparing this expression with this one of these expressions, here you see here x of minus n e raised to minus j omega naught n. This is here, we'll got this. X of n, this here on term is there. Therefore, here from this, comparing this equation and this equation, we get the value of x of minus 1 as 1 by 2. Compare these two equations. When I compare this equation and this equation, I will get the value as this get cancels. We get the value of 1 by 2. X of minus 1 is 1 by 2. Because in this is our main equation, main expression of the signal. Comparing this with this, we'll obtain various values of x of minus 2, x of minus 1, x of 0, no term, x of 0 here. X of 0 is what? Here. This, comparing this with this, there is no value, therefore 0. Then x of 1, comparing x of 1 into e raised to j omega naught n with this equation, here same term is there, e raised to j omega naught n. Here this is there, therefore substitute this value this side, then this e raised to j omega naught n cancels, here as to e raised to j omega naught n cancels. Therefore, we'll get the value of x of n as 1 by 2. 1 by 2. Therefore, x of 1 is equal to 1 by 2. In place of x of 2, compare this with this. No term, only two terms are there. For that, we got value of 1 by 2, here 1 by 2, x of minus 1, 1 by 2, 1 by 2. Compare all the other terms, you will get only zeros. X of 2 is equal to 0, x of 3 is equal. Like all will be 0, values will be 0 except x of minus 1 and x of 1, because only two terms are there. The two terms are matches with this equation, therefore we will get the values for x of minus 1 and x of 1. For the remaining, the x of minus 2 minus 0, like this will get when we compare that one. Therefore these are the values of x of minus 2, x of minus 1, x of 0. We got this other values of x of k. From this we can calculate the other values of x of k can be calculated easily, since x of k repeats after a period n. Then we can find out the other what then we can find out the other values also. We have found out the value of x of minus 2, x of 0. Even we want x of minus 3. Here x of minus 3 is not there. Where here? No. X of no. My x of minus 4? No. X of 4? No. Like we, but since we know the period, it is a periodic signal, repeats every six sequences. Other values of x can be easily, since x of k repeats after period n. After six values it repeats, therefore we can find out. Here you see x of 0, x of here I will show you, that is here they have found out only here x of 2. By using this we know what is the value of x of 2. Then it repeats at regular intervals of time, since it is periodic signal. Therefore what we'll do, this x of 2 you will add plus 2 plus 6, because the signal repeats at interval of interval of 6 sequences. Therefore x of 2 plus 6, then minus 2 plus 6 will be x of 4. By knowing that this x of 4 equal to 0, therefore x of already we have calculated what is the value of x of minus 2, it is 0. From this value we can obtain the value of x of 4. Why? Because the signal repeats for every 6 sequences, that is time period is 6, n is equal to 6. Periodic signal means what? A signal which repeats at regular intervals of time. It is called as periodic signal. Even discrete time also, in discrete also, periodic signals are there. There also we can represent sine wave as discrete time signals. You already we have discussed all those concepts. Then we know the value of x of minus 1. From this we can obtain the value of x of 5. Simply add 6 here. Everywhere add 6, 6 will get the other values also. Then what is the value of x of minus 1? X of minus 1 is equal to this will be x of 5. What is the value of x of here x of minus 1 is value is 1 by 2. Therefore, if it is this value is 1 by 2, then x of 5 value is also 1 by 2. Because go on adding with the 6 everywhere, we will get the sequences, the values of other sequences also. X of 4 is 0, x of 5 is 1 by 2, x of 6 is 0, because here x of 0 is what? X of 0 is 0. Like with adding 6, we'll get other values also. X of 4, x of 5, x of 6. These values we don't know, but we know these values. Simply adding 6, we get these values of x of 4, x of 5, x of 6, x of 7, x of 8, x of 9. Like this, we'll get the values of other sequences also. Next, similarly, what we'll do, x of minus 2, we know that we'll do subtraction minus 2, so that we'll get the what is, this is x-axis. On x-axis we can find out what are the values of this x of minus 2, we know. Add minus 6, then we'll get x of minus 8, x of minus 0, x of minus 1 plus we add then x of 7, why x of 7 is 1 by 2? Already the previous this we got the value of x of here x of minus 1 is 1 by 2, 1 by 2. Therefore x of minus 1 is equal to, it is equal to, add what with x equal to minus 1 minus x. Therefore it will be equal to x of minus 7. This x of, it means that x of minus 7 is equal to x of minus 1, x of minus 1. X of, already we have calculated what is the value of x of minus 1, that is 1 by 2. Since it is a periodic signal, signal with periodic sequences, like this we will get various values of x of minus 5 is 1 by, why? Because it is x of 1, we know the what is the value of x of 1, it is 1 by 2. Like we'll get so many values of different sequences. That is what x of 4, x of 5, x of 6, x of 7, x of 8, x of 9. Then here similarly negative x of minus 8, x of minus 7. Here we can represent towards negative values, minus 1, minus 2, minus 3, minus 4, x of minus 5, x of minus 6. Like this we can represent here also x of 1, 2, 3, 4, like this. Therefore, from these values, we obtain, this is our expression. This is spectrum of cos n pi by 3, where we have got the value of 1 by 2, 1 by 2. Suppose this is our value of 1 by 2. At what value we got 1 by 2? You see here. Here at x of 1 is 1 by 2, x of minus 1 by 2, and here rest of this is 0 0. Therefore here what is the value of, this is our x of 1 is, what is the value? 1 here. This is our x of minus 1 value. What is the x of minus 2? 0. Therefore we are not represented by any sequence. X of minus 3, 0. X of minus 4, 0. X of minus 5 is 1 by 2. How? X of minus 5, here you see x of minus 5 is 1 by 2. Like this we will get here what is where x of minus 7, x of minus 7 is 1 by 2, whereas x of minus 6 is 0. Therefore we have not represented any sequence here. Like here also what is the value of x of 2? X of 2, 0. X of 3, 0. X of 4, 0. X of 5, here we are having x of 5 some 1 by 2. Therefore x of 5 is 1 by 2. Like this we will have the sequence repeats here for every 6 sequences. Therefore we are like this, we x of 7 is 1 by 2. We'll see whether what is the value of x of 7. X of 7, x of 7 is 1 by 2. Therefore we obtained the spectrum, the signal x of k, the spectrum of a cos n pi by 3. This is the signal which we represented by cos n pi by 3. Important and interesting concepts related to TTFS. Such questions will be asked in exam. Definitely, such questions will be asked in exam for 10 marks, 12 marks. For example, I'm telling you some one problem. So they may ask so many different 3 to 4 different. You should solve. You should understand 3 4 such problems, because this problem only not such questions will be asked. Here I have taken the signal as cos n pi by 3. They give another signal. At that time, you have to, using these concepts, you have to find out what are the sequences, how we can plot the spectrum. For understanding purpose only, I am discussing. I have taken only one example as a sample example to understand the concepts. There are so many problems will be there. In question bank also, they asked various types of problems related to how we can find out the details of a particular signal. Understand the concepts and solve the other problems, similar problems which are there in the book, textbook, refer Alan Oppenheim and that S.S. Nawab, and you refer Simon Hacking. You can refer this video book. So many books are there. Even you can refer if you have not understood any concepts. Refer so many videos are there in that is Google Chrome in internet. So many. Simply you type the video lectures on signal system related to DTFS related, you'll get so many concepts are there, so many even nodes are also there in the internet. Search the nodes on signal system, you'll get so many nodes, so many concepts, so many what, so many mm video lectures and also so many notes, so everything is there in the internet. Search. If you not get the book textbook, if you are not having any textbook, simply refer the internet in mobile also. If you are having the net, you can in mobile also you can watch so many hundreds of video lectures related to DTFS, CTFS. You refer. If you the main thing is that you should be very serious and understand the concepts and perfect that one, then definitely you can score good marks in signal system. Okay, this third module is over. In next class onwards, I will discuss about the fourth module, that is about representation of signals, Fourier transform. This Fourier series over. In next class onwards, I will discuss about the fourth module, that is signal represented by how we can analyze non-periodic signal using the concept of Fourier transform. Okay, okay. Thank you.